To design a low-pass filter LPF for the 80-meter band, the most common approach is the pi network ladder filter. This design uses a ladder of capacitors and inductors to create a steep roll-off, ensuring your transmitter doesn't spray harmonics into the higher bands. For an 80-meter transmitter, a 5-pole or 7-pole Chebyshev filter is the gold standard. To keep your 80-meter signal clean while protecting the 40-meter band, we need to set the cutoff frequency FC slightly above the band edge. Design cutoff is 4.2 MHz. This gives you breathing room for the 4.0 MHz edge in case of 80-meter band as in most regions. Here the upper end is 3.7 MHz. System impedance or Z0, 50 ohms, standard for most transceivers and antennas. Filter type 5-pole Chebyshev, 3 capacitors, 2 inductors. Like the low-pass filter in VU2 EVQ linear amplifier, which I am homebrewing. The 5-pole ladder filter for 50 ohm system usually starts and ends with a capacitor to the ground. The arrangement looks like this: C1 input capacitor to ground, L1 series inductor, C2 sender capacitor to ground, L2 series inductor, C3 output capacitor to ground. For a 5-pole Chebyshev filter with a 4.2 MHz cutoff at 50 ohms, C1 and C3 will be 820 picofarads with 1 kilovolt rating and excellent quality capacitors, not the usual small ceramic capacitors. C2 again 1500 picofarad with 1 kilovolt rating. L1 and L2 2.8 microhenry, approximately 25 turns on a T52 core. Cheap quality ceramic capacitors will heat up and drift under RF power, which shifts the cutoff frequency. We can wind the inductors ourselves. For a compact high efficiency build, T52 iron powder toroids are ideal for the 80-meter band for 100 watt SSB. To achieve 2.8 microhenry on a T52 core, 25 turns of 22 AWG enameled wire. Spread the turns evenly around 3/4 of the core to minimize stray capacitance. If long duty cycle as in digital modes are being planned, higher toroids like T68-2 or T82 cores may have to be used to handle the heat generated. Good ventilation should also be there. T68-2 core needs 23 turns for 2.8 microhenry. Heat generation will be more if SWR is high and with long rack tubes. Once assembled, it should be ideally tested before hooking up to the transmitter. Nano VNA can be used. Look for the S21 log mag plot to see where the signal starts to drop off. It should stay flat until 4 MHz and be significantly in the basement by 7 MHz. SWR check. Connect a 50 ohm dummy load to the output. SWR should be near 1.1:1 across the entire 80-meter band. It is a good idea to seal the toroids after confirming SWR with a dab of hot glue or clear nail polish to prevent the wires from shifting